right, so in this build work here, I'm solving for this system of equation using substitution. Now, when you're using substitution, you have to solve for a variable first. Now, in the previous problems, I've actually had y, or one of the variables, already solved for you. In this one, that's not the case. So what I have to do first is to solve for a variable. And when I'm looking closely at it, I think y in the first equation would be the easiest to solve, because all I have to do is move the 3 over and then move over this negative sign. So I'm going to choose to solve for this y value right here, okay? And so like I said, I'm going to scoot over the 3, subtract the 3 on both sides, so then they would cancel. And so on this side, maybe I'll just scoot the equation over. This would be negative y equals 10 minus 3x, and then I would just divide by a negative 1 here, and so then that would cancel. So y is equal to negative 10 plus 3x after I divide by a negative 1. So here's my equation, and I've solved for y. So I'm going to use what y equals, which is this piece right here, negative 10 plus 3, and plug it in to this second equation's y, so I can solve for the variable. So what I'm going to do is down here, I'm going to write out 2x plus 5. Instead of y, I'm going to put parentheses and plug in negative 10 plus 3x equals 1. And so I'm going to distribute this negative 5 here, and I'm going to carry down the 2x, which gives me 2x plus, oh, actually not plus, negative 50 plus 15x equals 1. Then from there, I'm going to try to combine like terms, like these two numbers actually combine to give you 17x. Then the negative 50 comes down as itself because there's no numbers to combine. Then I would add the 50 over to the other side. That would cancel. 17x comes down. This is 51. Then I would divide by 17 with 51. Okay, so if I were to plug this into my calculator, 51 divided by 17 is actually 3. It's a nice number. So now I'm going to take this 3 and I'm going to plug it back into one of my equations. So I can plug it back into one of these equations, or I can plug this 3 back into the equation that I solved for. So this this equation I actually solved for y. So it'd be easier to use this equation, and I plug the 3 in, and I immediately get y. So let's do that. So I'm going to take the y equation, negative 10 plus 3, but instead of x, I'm going to plug in 3. So if I work this out, this is negative 10 plus 9. 3 times 3 is 9, and so y is equal to negative 1. And so my x is 3, my y is negative 1, so this is 3, negative 1 for my intersection. So if these two lines were graphed, they would hit at 3, negative 1. All right, so that's what we learned last time. I want to get into today's lesson, which is elimination for solving systems of equations. Okay, so we're now on to our third method for solving systems of equation. Last time we learned how to graph, and we learned how to use substitution. So elimination is where you take your equations and you line up the x's and y's. And then afterwards, you're going to choose a variable you decide to cancel out. Now, to cancel a variable, you need to, the variables need to have the same coefficients. Let me write this in. The same coefficient, meaning the number in front of x or the variable. And they need to be opposite signs. So in other words, like if you have a 2x, a positive 2x, the only way to cancel it out is if you have a negative 2x. That would allow it to cancel out. Or if you have a negative 3x, the only way to cancel out is to have a positive x, okay? And then that would cancel them out when you add them. So elimination looks at opposite signs but the same coefficients or the same number in front. And then you always add the equations together, which allows you to cancel. All right, so let's do a few examples from the homework. So here in the first example, this is number 35 from the homework, and you can see I have my x's and y's already lined up. So this is, the step 1 is already done for us. And if I were to stack them and add them immediately, the x's already will cancel out because that's a -2, that's a +2. They will cancel when added. So that leaves me with the y, so 3y plus -5y is -2y. Bring down the equal sign. -16 plus 24 gives me a +8. And so notice that once I cancel out the x's, I'm just left with y. So this becomes so easy to solve for one variable. So I divide both sides by -2, that cancels. My y is equal to -4. So I have my y. I need to find my x now. So I go back to one of these equations. It doesn't matter which one. So I'm just going to plug it into the first equation. Really doesn't matter. So -2x, because I don't know x, 3 times y, which is -4, equals -16. So if I work this out, this is -2x minus 12 when I multiply. And then I would have to add 12 to both sides. That cancels. -2x comes down. -16 plus 12 gives me -4. Yes. So then from there, I'm going to be dividing both sides by a -2. That cancels. So x is equal to +2. So my intersection here happens to be at 2, -4. And I have one solution here because there's only one coordinate here. Now for this one here, I have a 2x, a -5y, and a 3x, and a y. And so I have to think about which variable do I want to cancel. And for me, I think the y's would be nice to cancel because they're already opposite signs, right? You need to make sure they're opposite signs to cancel. And that coefficient there is technically a 1. So if I really wanted to, I can multiply the second equation by +5 because 1 can easily become a 5 if I multiply it by 5, right? So here's the thing. The first equation, I'm not going to do anything to. The second equation, I am going to multiply this 5 into the second equation. And when I do, I multiply it to every number inside. So here's what I'll do. The first equation didn't touch. So I'm going to copy and paste it down. The second equation I did, or I'm going to multiply by 5. So 5 times 3x is 15x. 5 times 1y is +5y. And 5 times 8 is 40. And then from there, I'm going to add. We always add the two equations. And so immediately the y's will cancel because they're opposite signs, same coefficient. And then 2x added with 15x gives me 17x. And then 11 plus 40 gives me 51. Deja vu. Didn't I do that in the bell work? Well, I guess we're doing it again. So divide by 17. I already know the answer is 3. So x is equal to 3. Now I just need to find y. So I think I'll just plug 3 into the second equation since that's just like a 1y already. So if I plug in 3, y will already be easily by itself. So I'm going to take the second equation. And remember, it didn't matter which one I plug it into. I just chose the second one because it's more convenient. So here's the second equation. I'm going to plug in 3 for that x. So that's going to be 3 times 3 plus y equals 8. So that's 9 when I multiply. Y equals 8. So if I subtract by 9, y is equal to, well, 8 minus 9 is -1. So the intersection here is 3, -1. And I have my answer. All right, so now that we've had some practice here, let me show you 3 more cases that are a little bit strange, but very doable. Okay, so in this problem here, let's start with 40. And you'll notice 40 here, there's nothing that's going to cancel, right? So this is a situation where you have to force things to cancel. And so I'm going to just label these first, just number them. And what I'm going to do is maybe cancel out the y's. So I chose the y's because they have smaller coefficients and it's easier to work with smaller numbers. So 3 and 2. 3 and 2 can both multiply to give me 6, right? So if I wanted both of these to be a 6, all I have to do to the first equation is multiply it by a 2. All I have to do to the second equation is multiply it by a 3, right? Because 2 times 3 gives me a 6, 3 times 2 gives me a 6, and I'm good to go. I have the same coefficient. But both of them are both positive, so that means I have to choose one of these to be a negative, and I'll just choose the top to have a -2. It really doesn't matter, but just the top, so that way one of them could be a negative to cancel out. So now I'm going to distribute this -2 in for the first equation and the +3 into the second equation, and write it down. So my first equation will be -8x minus 6y equals -2. And my second equation will be 9x plus 6y equals 6. And then I'm going to add these two equations. So the y's cancel because they're opposite signs and same coefficient. And then if I take the -8 and add it with +9, that gives me a 1x, or just an x. And then this side here, -2 plus 6, actually gives me a +4. And so I found my x, which is great. So now that I have x, I can go find my y. So I'm going to plug this x into the first equation. It really doesn't matter which one I decide, but I just choose the first equation. So first equation is 4 times x, which is 4, plus 3y equals 1. So 4 times 4 is 16, plus 3 equals 1. So I have to subtract by 16, it looks like. So that cancels. 3y drops down. 1 minus 16 is -15. Divide by 3 is y, -5. -15 divided by 3 is -5. So my solution is 4, -5 for my coordinate. And that is my intersection, or my solution. Okay, so let's try out 2 more where we might get something really strange, and I'll show you what I mean when I get into it. So the first one of this equation is, your 5's as your coefficients, and then your second equation just has 1's as your coefficients. So I can't cancel them out right away, but if I multiply maybe the bottom by a 5, let's see if I can try to cancel out the x's. So if I decide to cancel out the x's, this needs to be a -5. So what I'm going to do is multiply this bottom equation by -5, and I'm not going to do anything to the top equation to cancel. So I'm going to copy and paste down the first equation for the top. The second equation, if I distribute a -5, that is -5x. -5 times -y is +5y. And -5 times +12 is -60. So if I add these together, the x's and the y's cancel out, leaving me with just 0. But 3 plus -60 is -57. And last time I checked, 0 does not equal 57. So if the numbers don't match up, they can't equal each other. So that means I have a no solution because this is inconsistent. So this is no solution. All right, so anytime you get a mismatch of numbers, that's when the answer is inconsistent and you just say there's no solution. All right, let's try out this one here. So this one, the x's and y's are not lined up well. I mean, the x's and y's do line up, but this y is not on the other side, and it needs to be in standard form when you're doing elimination. So first things first, I'm going to move this y over to the other side. It looks like since those both are negative, I'm going to add it over. So I would really have, let me write it over here. Really have 2x plus 3y plus, sorry, not plus, equals 1. And then 6x plus 9y equals 3. So this is really my first equation and second equation. And so looking at it, they don't cancel immediately, but all I have to do, like let's say I want to cancel out the x's. This is a 2, so I can make a 2 a 6 if I multiply the top by a 3. But I want to use a -3, so then that becomes a negative sign, and that's a positive sign. So if I were to do this, the first equation will end up being -6x, -9y equals -3. And then the bottom equation, I did nothing to it, so I'm just going to copy and paste it over. And so when I'm looking at this, it's like, gee, that cancels. So all I'm left with is 0 on the left-hand side again. And then, but the right side also cancels, right? So if they cancel, then I'm left with 0 on this side too. Well, 0 does equal 0, so this is a true statement. So anytime all your equations cancel to give you zeros, this is what we call infinitely many solutions. And the reason why is because in this case, this is saying that they both cancel out perfectly, meaning that they had to have been the same line. And if they're the same two lines, right, that means that they are always intersecting each other. In other words, there are infinitely many solutions because there's an infinitely many intersection. So, to kind of wrap things up, let's summarize what we just noticed. All right, so most of the time you notice that when I solved it out, I got an x value, some number, and a y value that was some number. So like one of the examples that I had, like in problem 40, I got x equals 4 and y equals -5, or sometimes I write it as a coordinate. Either way, this is what we call a one solution. No solution is when you have some sort of inconsistency. So when you saw me have like everything cancel on my left-hand side and then the other side subtracted to give me -57, this is what an inconsistency looks like, because you can never have two numbers that are different that would equal each other. So this is what leads to no solution. And sometimes everything cancels out and both sides equal the same. So you could have 0 and then this side maybe also equals 0. And so if you have this situation, this is infinitely many solutions. All right, so last slide for today is the exit problem. So try this one out on your own. If you figure it out, make sure to ask for a stamp in class. All right, here is the exit ticket problem. So you're going to solve this out using elimination and find x and y. So like I said, if you solve this out, show your work to me. I will give you a stamp. All right, until next time, guys. Bye.